This is an in-depth walkthrough of how to configure the Q90R2 Radar Sensor with the Banner Measurement Sensor software. If you need information about the general features and functionality of the software, check out our Banner Measurement Sensor software overview video. After connecting your Q90R2 sensor to the software, you will see the 2D Scatter tab. This is a visualization of the sensor's field of view in 2 dimensions and allows the user to see and adjust the independent output set points and view detected targets. The primary targets will be displayed in this 2D scatter graph represented by either a green or blue dot, which pertain to discrete outputs 1 and 2 respectively. The legend at the top right corner of the graph allows the user to hide or display which data appear on the plot. This includes the ability to display the active targets within the field of view. The Q90R2 can detect and differentiate between static and dynamic targets, and these targets can be displayed as live sensor data in the 2D scatter graph. In the top right corner of the screen is the summary pane, which displays 2 lines of data corresponding to the 2 outputs of the device. The Q90R2 can detect and measure 2 independent targets, and the data for those targets include the distance, velocity, angle, and signal strength. The output status is also represented in this pane. In the General Settings tab, you can configure many of the settings common to Banner measurement devices. The response speed can be modified to improve performance based on the application needs. A slow speed may be used in situations where a more precise measurement of slower targets is required, or a fast speed may be used for applications that require a quicker update rate. Note that the response speed is reported in the Output tabs. There are 2 types of detection areas that can be defined: radial and rectangular. Radial windows are defined corresponding to the radial distance from the sensor, whereas rectangular windows are defined in the X and Y coordinates noted on the top left-hand corner of the 2D scatter graph. Both can be adjusted either directly in the 2D scatter or within each output tab. There are various target filters which apply to both outputs. Signal strength threshold can be used to filter out signal noise such as from ambient weather conditions. The minimum and maximum sensing ranges can be adjusted to filter out the measurement of targets in the near range, such as an enclosure, or in the far range, like when there is a known maximum distance, such as in a tank level measurement. Velocity filters allow the user to choose a classification of target based on its velocity. The default of all targets means that both static and dynamic targets are detected. Selecting dynamic targets only means that only targets with a velocity will be detected. Additional velocity filters include approaching targets only, for which only targets with a negative velocity are detected, or receding targets only, for which only targets with a positive velocity are detected. A custom velocity filter can be defined by selecting Custom and using the sliders to define the limits. The Advanced Targets section contains settings for detection sensitivity and a measurement filtering method called Measurement Hold. We will discuss this section in greater detail in another video. Additional settings in the General tab include sensor polarity, sensor lockout, and indication, which will allow the user to define the remote input polarity, disable the remote input wire of the device, and turn the LED indication off, respectively. Configuration of the individual output settings is done within the 2 discrete output tabs to the right of the General Settings tab. Adjust the output mode as either a switch point, for which a single switch point distance is defined, or as a window, for which 2 set points are defined to create window limits. Detection area settings include configuration of the target mode. Use strongest target when it is required that the output responds only to the target with the highest signal strength. Use nearest target when it is required that the output responds to the target closest to the sensor. For both target modes, the measurement data corresponds to the target in the active sensing area, and the output state responds to the limits that have been defined in the target filters of the General Settings tab. Next, users can configure the detection area switch points. Note that the output window settings can be adjusted directly from the 2D scatter graph by clicking and dragging the switch point lines displayed on the plot. These adjustments are reflected within the detection area settings drop-down menu and vice versa. The last parameters that can be adjusted in the Discrete Output tab are the output settings, which include the default output state as well as on and off delays. The Response Speeds section reflects the response speed as defined in the General Settings tab plus any additional delays. In the Discrete 2 tab, 2 additional output modes can be selected: Complementary or PFM. Complementary will cause discrete 2's output to be opposite of discrete 1. PFM, or pulse frequency modulation, allows for easy interface with Banner Pro lighting products or a PLC with a PFM input. Additional information about the PFM output configuration will be detailed in another video. That covers the basics of configuring the Q90R2 Radar Sensor with the Banner Measurement Sensor software. For more information, visit bannerengineering.com.